Welcome to Introduction to Nanotechnology. My name is Dr. Radhanarayanan, and I have a PhD in analytical chemistry from Georgia Institute of Technology, and my research focuses have been on nanocatalysis and nanosensing. I also have a broad background on a variety of different applications of nanotechnology. If you enjoy this video, please click on the like, subscribe, and share button below. That way, you can get notified when I post new videos to the channel. So, the question is, what is the definition of nanotechnology? Basically, nanotechnology is the study of materials between 1 to 100 nanometers in scale. You might ask, why is this length scale important? The reason is that the length scale of 1 to 100 nanometers is between that of single atoms and bulk molecules, and there is a dramatic change in the properties of materials in this length scale. As the size of the nanoparticles decreases, there is large surface area to volume ratio. Molecules can be conjugated to the surface of the nanoparticles. The figure is an artistic rendition showing gold nanoparticles having molecules conjugated to them. Now, the question is, what does nano mean? The definition of a nanometer is 1/1000th of a meter. Let us put this into perspective. See the four figures on the right. The first one is human hair, which has a size of 100 micrometers, and the next figure on the right is a picture of an ant which is approximately 4 millimeters in size. The third picture on the left is a DNA helix, which has a size of 2.5 nanometers. As you can see, the DNA molecule is within the size range of 1 to 100 nanometers in length. The last picture is that of bacteria, which have a size of 2.5 micrometers. Overall, it can be seen that the individual nanoparticles in the size range from 1 to 100 nanometers is too small to seen by the naked eye, just like DNA helix cannot be seen by the naked eye and requires the use of specialized imaging equipment to visualize the nanoparticles. So, the question remains, why is the 1 to 100 nanometers length scale so important? There is an increase in the surface-to-volume ratio as the size of the nanoparticles decreases. In addition, there is a dramatic change in the properties of materials in this length scale. Some examples of properties that change upon changes in the sizes of nanoparticles include the absorption spectrum for gold, silver, and copper nanoparticles. The surface plasmon band redshifts as the size of these three metallic nanoparticles increases. Another property that changes is that the color of the nanoparticles changes as the size of the nanoparticles increases in the case of silver and gold nanoparticles. In addition, in the case of gold and silver nanorods, there is both a transverse and longitudinal surface plasmon band. The longitudinal plasmon band redshifts as the aspect ratio of the gold nanorods increases, while the transverse band remains in relatively the same position. There are also other properties that changes when the shape of the nanoparticles changes. Other shapes like cube, prisms, bipyramidal, and nanoplates have surface plasmon bands that are redshifted, and there are also color changes in the nanoparticle solution. In the case of nanocatalysis, tetrahedral platinum nanoparticles have been shown to have increased chemical reactivity compared to spherical and cubic platinum nanoparticles. Changes in the shape can give rise to greater effects of the electromagnetic enhancement effect, in which there is amplification of local electric fields near the nanoparticle surface, as well as the lightning rod effect, in which there are greater electric fields at sharp tips and corners. The schematic on the right shows examples of different types of shapes of nanoparticles that can be synthesized. The picture on the right is an example of macroscopic crystals. In our case, the nanoparticles are nanocrystals with specific crystallographic facets such as 100, 111, and 110 facets. Different shapes are composed of different facets. Cubic nanoparticles are composed entirely with 100 facets, while tetrahedral nanoparticles are composed entirely of 111 facets. Nanorods contain 110, 100, and 111 facets depending on the specific location on the nanorods, like the long face, sides, corners, and edges. To summarize this introduction to nanotechnology, materials between 1 to 100 nanometers are of great interest since they have different properties compared to the atomic scale and bulk materials. As the size of the nanoparticles decrease, there is an increased surface-to-volume ratio of the nanoparticles. Some changes in the properties of nanoparticles include changes in the absorption spectra, changes in the electric field, changes in the chemical reactivity, changes in the electromagnetic enhancement effect, as well as the lightning rod effect. If you like this video, please click on the like, subscribe, and share buttons below. That way, you can receive notifications of new videos that I post.